Good morning, my students and good listeners at home. I'm Mrs. Chine from St. Charles College, Onitsha. I teach physics. The topic we are going to discuss this morning is waves. Specific objectives. At the end of the lesson, the students should be able to define waves, wave motion, state 2 types of waves, give 4 types of mechanical waves, mention 3 differences between mechanical waves and electromagnetic waves, define basic terms used in describing wave motion, state 5 properties or characteristics of waves, do simple calculations. Definitions. Wave. A wave is a disturbance which travels through a medium, transferring energy from one point to another without any permanent displacement of the medium. Wave motion. Wave motion is a process of transferring energy or disturbance from one point to another without any transfer of particles of the medium. Types of waves. There are 2 types of waves, namely mechanical waves. Mechanical wave is a wave that requires material medium for its propagation. Examples are water waves, sound waves. The next one is electromagnetic wave. It's a wave that does not require material medium for its propagation. Examples are radio waves, X-rays, gamma rays, etc. Types of mechanical waves. Mechanical waves are of 4 types. 1. Transverse wave is a wave which travels perpendicular in the direction of propagation or vibration of waves. Example, water waves, light waves, radio waves. Longitudinal waves is a wave in which the vibration occurs in the same direction traveled by wave. Example, sound wave. Then the next one is standing or stationary wave. This wave occurs when 2 waves of the same amplitude, frequency, time are traveling in opposite direction in a straight line. Progressive or traveling wave. This occurs when a traveling wave moves continuously from a point to another point. Differences between mechanical waves and electromagnetic waves. Mechanical waves travel at the speed less than the speed of light, while electromagnetic wave travels at the speed of light. Mechanical wave requires material medium for its propagation, while electromagnetic wave do not require material medium for its propagation. Mechanical wave occurs both in transverse wave and longitudinal wave, while electromagnetic wave occurs only in transverse wave. Basic terms used in describing wave motion. Amplitude is the maximum displacement of a particle from its equilibrium position. It is measured in meters. Crest. Crest is a region of maximum upward displacement. Trough. Trough is a region of maximum downward displacement. Wavelength. Wavelength is the distance between 2 successive crests or 2 successive troughs. It is measured in meters. Period. Period is the time required to make one complete oscillation or vibration. It is measured in seconds. Frequency. Frequency is the number of complete oscillation in 1 second. It is also the reciprocal of the period. It is measured in hertz. Properties of waves. We have 5 properties of waves. They are reflection. Reflection is the change in the direction of waves when they hit an obstacle. Refraction. Refraction is the change in the direction of wave when a wave travels from one medium to another of different densities. Diffraction. Diffraction is a phenomenon whereby waves bend round obstacles. Interference. Interference occurs when 2 waves from a source cross each other's path. Polarization. Polarization is a confinement of waves in one direction. reflection, refraction, diffraction, interference occur both in transverse wave and longitudinal wave, while polarization occurs only in transverse wave. Let's go to mathematical relationship between frequency, wavelength, and velocity. The frequency, wavelength, and velocity of all waves are related by a relation given by velocity equals frequency multiplied by wavelength. That is V equals lambda F. We call it equation 1. And this equation 1 can be proved. Then velocity or speed of a wave is given by distance traveled by time taken. If a wave travels a distance in one cycle and the time it covered in that one cycle, we call it a period. Then velocity can be given as wavelength will now replace distance traveled, while period will now replace time taken. Then velocity now becomes wavelength divided by period. But remember, frequency is equal to reciprocal of the period. Then velocity now becomes wavelength over period, which is equal to wavelength multiplied by 1 over period. Then velocity now becomes wavelength times frequency. We have proved it, which we said velocity equals wavelength multiplied by frequency. Let's take example. Example 1. The frequency of a vibrating source is 450 Hz and the velocity of the sound in air is 330 meters per second. Find how far the sound travels when the source completes 50 oscillations. Then solution, we bring out the parameters. The first one is the frequency, which is equal to 450 Hz, velocity 330 meters per second. Then we are given number of oscillations, which is represent n. Then velocity or speed equals distance over time. And remember in physics, where how far is equal to distance. Therefore, if we make distance the subject of the formula, we have distance equals velocity multiplied by time. Then let us recall that period, when we did simple harmonic motion, that our period is equal to time over n. That is time for number of oscillation divided by number of oscillation. Then we call it equation 1. Then remember T represents period and number of oscillation. Recall that T equals 1 over F. Then from that equation 1, we make small t the subject of the formula, which becomes period times n. Recall that T equals 1 over F. Then we have small t equals 1 over F times n, which is, if you substitute, we have 1 over 450, which we know is our frequency, multiplied by n, which is known is our what? Number of oscillation. Then if you simplify, we have our answer to be 1 over 9 seconds. Remember, we are asked to find distance travel in the question. Then our distance travel, or how far now, becomes velocity or speed multiplied by time. If you substitute, we have 330 multiplied by 1 over 9, which is now equals 36.67 meters. Then let's go to example 2. A radio station broadcasts at at the frequency of 300 kilohertz. If the speed of the wave is 3 times 10 raised to power 8 meters per second, calculate the period and wavelength of the wave. Solution: bring out the parameters in the question. Frequency now becomes 300 kilohertz. Remember that kilo is 1000. So that frequency will be 3 times 10 raised to power 5 hertz. Then velocity, which is given in the question, equals 3 times 10 raised to power 8 meters per second. Then we are asked to find period. Then period is 1 over frequency, which is equal to 1 divided by 300 times 10 raised to power 3. That 10 raised to power 3 represents K, which is the kilohertz. Then, if you simplify, we have 1 over 3 times 10 raised to power 5. Simplifying, we have period equals 3.3 times 10 raised to power minus 6 seconds. Then the next one is wavelength of the wave. Then we quote the formula. Wavelength of the wave now becomes velocity multiplied by frequency. Recall the velocity of the wave, which is v equals f lambda, frequency multiplied by wavelength. So if you make wavelength the subject of the formula, we have velocity over wavelength. Then when you substitute, we have 3 times 10 raised to power 8 divided by, remember 3 times 10 raised to power 8 is our velocity, and then our frequency, don't mind that frequency is 3 times 10 raised to power 5. Then the answer becomes 1000 meters. And that 1000 is equal to kilo. So we have 1 kilometers. Then let's go to mathematical representation of wave motion. So wave motion can be represented mathematically by the equation given by A equals A sine bracket 2 pi ft minus 2 pi x over lambda. Then let's define the symbols given. Y equals vertical displacement. X equals horizontal displacement. Capital letter A equals amplitude. Small t equals time. Then 2 pi f equals angular velocity. 2 pi x over wavelength equals phase angle. Then let's take exercise. Exercise 1, example 1. A plane progressive wave is given by the equation y equals 2 sine bracket 2000 pi t minus 0.5x, where the symbols have their usual meanings. Find A, amplitude, B, frequency, C, period, D, wavelength, E, wave velocity. Solution. Recall the general formula for the mathematical representation of wave, which is y equals A sine bracket 2 pi ft minus 2 pi x over lambda. Then before we solve, we have to compare this general equation with the equation given. So if we compare the equation given, which is y equals 2 sine bracket 2000 pi t minus 0.5x. Then if you compare the two, you now see that amplitude now becomes 2 meters. Then to find our frequency, if you compare the two equations, you see that 2 pi ft now becomes equal to 2000 pi t. If you make F the subject of the formula, we have 2000 pi t divided by 2 pi t. If you cancel out 2 pi with 2000 pi t, if 2000 pi t divided by 2 pi t, we have 1000 hertz. Then the next one is period. Period equals 1 over frequency. Then when you substitute 1 over frequency, we have 1 over 1000. Remember, 1000 is a frequency. 1000 hertz is frequency. Then when you substitute, we have 0.001 seconds. Remember, the unit of period is second. Then we go to the next one, wavelength. For us to get our wavelength, we equate 2 pi x over wavelength equals 0.5x. If we make wavelength the subject of the formula, we have 2 pi x divided by 0.5x. If you simplify, you have 20 pi x divided by 5x. Simplifying or using your calculator, you have 4 pi meters. Then the next one is wave velocity. Remember, the formula for our wave velocity is frequency times wavelength. When you substitute frequency for 1000, wavelength for 4 pi, the answer becomes 4000 pi meter per second. Then before we go to our evaluation, let us just take a flash of what we did. Remember, we did a wave. What is wave? Wave is a disturbance that travels through a medium, transferring energy from one point to another without any permanent displacement of the medium. We see wave motion. We see types of waves as mechanical and electromagnetic waves. We look at the properties of waves. We look at basic terms used in describing waves. Then now let's go to the evaluation. Define A, waves, B, waves motion, state 2 types of waves, mention 4 types of mechanical waves, give 3 differences between mechanical waves and electromagnetic waves. Define basic terms used in describing wave motion. Mention 5 properties or characteristics of waves. Then do this calculation. A radio station broadcasts at a frequency of 300 kilohertz. If the speed of the wave is 3 times 10 raised to the power 8 meters per second, calculate the period and wavelength of the wave. Answer the question and then send the answer to my WhatsApp number 080-631-613-55. Thanks for listening and bye.